I'm more than a little surprised by the DF team's incredulous perspective surrounding the quote-unquote 8K performance mode of a PS5 Pro. Back when the PS4 Pro launched, you guys had an excellent video explaining how the revised quote-unquote 4K console could greatly benefit users with 1080p TVs, with the most obvious win being pristine anti-aliasing via supersampling. It's not about 8K TV adoption, it's about doing away with the awful jaggies.
Well, you know,
Yeah, Tom,
there are.
thoughts?
I mean, gut reaction is there's a lot of ways to treat those jaggies for a lot lower GPU cost without having to ramp up the pixel count all the way. Wow, that was a good synchronized
That
water
was.
glove
I
there.
noticed that.
Yeah,
But
you're
not much
quite
more to
right.
say. You know, it is what it is. I don't think 8K TV adoption will be the primary driver of a new console upgrade. Personally, I could be
Yeah,
wrong, but I just don't see it as.
yeah, I get what the poster is saying here, that what the question is suggesting. The issue is that there was a reason for 4K resolution rendering, right? It was because there were 4K displays out there in reasonable enough volume that, it kind of made sense. There isn't really that proliferation of 8K
Well,
screens.
he's talking about downsampling, though. He's saying if you have an 8K mode, that if you use that mode on a 4K display, you should get better image quality. But I don't really think that's... So I actually think this all ties into just the evolution of image quality in games and why things have continued to shift. And this goes back to, I still see some confusion around this. If you look at the early days of Digital Foundry, we're talking about different resolutions on there and everything. And it's like, there's a small number, like if you look at the total number of pixel difference between like, say, I don't know, 640p and 720p, right? Like a PS3 versus 360. It's not a gigantic amount of pixels that are different between them. But when you consider the anti-aliasing technologies of that era and the types of displays in use and like the size of the pixels as they're presented, that difference felt huge, right?
Yes.
If you have
Yeah,
bad
absolutely.
quality AA or no AA and you're displaying at that resolution, like it looks hugely different. It's much, much different. It's like going from 480p to 720p. That's a huge leap. But if you go from like 1800p to 2160p, most people won't even be able to detect that unless they get close to the screen, right? But it's not just about the total pixels, it's also the anti-aliasing, right?
Yeah.
Anti-aliasing has continued to evolve. And in 2016, when the PS4 Pro launched, TAA had started to proliferate, but it wasn't nearly as refined as it is now, and it wasn't as common. Where there was still a lot of FXAA out there and things like that, right? Like post-process AA. That stuff does not look that good on its own. So actually downsampling from a higher res back to 1080p really helped a lot more there. I think with the way modern AA works and all the other techniques that we have for current generation games, that you don't really need that as much unless you were natively doing a much higher resolution. Like if you actually were rendering a full 8K's worth of pixels, then yeah, you get a nice benefit from that. But I think the point is that these consoles won't be able to do that. It would be like doing, you would be upscaling, then downscaling again.
Which happened
Basically.
on PS4 Pro, right? Because if you had a 1440p game that was upscaled to 4K and you used the super sampling
That's
feature on the
true.
Pro, it double scaled. It scaled up to 4K, then down to 1080p, and you got this sort of double
It,
scaling effect, which wasn't ideal.
exactly. It didn't always look that great in the end. It actually impacted the clarity on things. It kind of blurred out the image a little bit more. It wasn't as much of a home run as you might think. And because
Yeah.
of that, I don't think this would make a huge difference. Only in select cases, like something like how we have The Tourist, which already does this basically, which is an 8K 60 game, right? That downsamples from native 8K to 4K, and yeah, you get the benefits of that big time, but that's also a game that didn't really use anti-aliasing, and it's a very simple designs and like harsh structures and edges that really benefits from it. But most other games, I don't think you'd see a huge difference.
Yeah, it's an interesting idea. I mean, it's all going to depend on what this, assuming it's actually real, of course, what this mystery 8K mode, performance mode, is actually going to take. Another thing, as Tom points out, is the GPU resources required. Now, there is the idea that it could be using a similar sort of technique as DLSS. And the issue there is that DLSS has its own computational cost. And DLSS also that the scale of that cost rises with the output resolution. So if the output resolution is 8K, then that's going to be quite significant. But actually, we might as well continue this discussion into the second question from Darjar Ko. Another happy half fortnight, gents. Naturally, I think the biggest news in the last week or so has been the rumoured PS5 Pro specs that look thoroughly sensible / realistic. Eagle-eyed spec inspectors will have noticed the mention of a quote-unquote custom AI accelerator. Given the history of the PS4's checkerboard rendering system, I wonder if you could speculate on what an AI-accelerated checkerboard implementation could look like. Could it use motion vectors to reduce shimmering and fast-moving scenes? I feel as though Cerny will be working on some kind of AI secret source, and wonder what kind of thing you think seems most likely.
I'm just imagining Mark Cerny himself sitting in some kind of like isolated laboratory working on that exact thing. Just Cerny by himself.
Yeah, not the team of engineers.
No.
Just Cerny. Yeah, I think, well, he is the system architect. He is, he leads the project, but it is a team effort, obviously.
Exactly.
I mean, I can't see. This could be just the limitations. I mean, when we go back to 2016 and the PS4 Pro, checkerboarding was in its infancy, but it was a technique that was known, that was developed. The concept, though, that it was built into hardware does suggest that Cerny and his team were looking at it very, very early, though, right? The fact that they baked it into hardware. So I'm wondering where they go from here. I mean, the most likely solution would be some kind of offshoot or derivative of DLSS, right? Because that's basically how all of the other upscalers work. They use the same inputs, essentially. They use the same sort of masking techniques. John, can you imagine any other sort of technique?
No, that seems extremely feasible. I think it's just we've seen DLSS continue to improve so much since these consoles have launched. Like that's clearly where we're going, right? So it would behoove them to make a hardware accelerated function that sort of tries to do something similar that's better, more accurate, faster than software-based FSR2, right?
Mm-hmm.
So this absolutely would make a ton of sense if they would pour time into creating custom silicon to handle these tasks in hardware, because then, you could actually get these higher resolutions for a much lower cost through reconstruction, and it would potentially produce results far superior to FSR2 by itself.
Mm-hmm. Yeah, agreed. It's all a matter of working smarter, then harder with just a simple GPU bump,
Well, this raises a question that occurred a couple of weeks ago with the launch of Remnant 2, where the developers were saying, well, actually, you really should be using upscaling with this game because we know it's heavy, but we are planning to optimize. I think the issue there is that it's going to take some time, particularly in the PC space, for people to understand that new features, cutting-edge features, come at a cost.
Yeah.
And therefore, to mitigate that cost, you do need to use upscaling. Nobody is questioning Cyberpunk 2077 RT Overdrive as requiring DLSS 3 to be actually performant, right? Because it's the ultimate cutting edge. You expect that there's got to be some mitigation in place. But similarly, we're kind of moving into early territory, pioneering territory with Unreal Engine 5. We're starting to see these next-gen features actually deployed, and it's going to take time for those features to be fully optimal. And progress is being made, but the games we're seeing today are being made on the Unreal Engine 5 of yesterday. So there's a certain degree of lag in there.
Interestingly, when we were talking to Nixis about the Ratchet Port, one of them noted that they actually subscribe to a subreddit that is focused on, I think it's like FTAA is what it's called, if you extrapolate from there. And it's a group of people that have gathered together to profess their dislike of TAA. They don't like modern TAA. They want their raw pixels. And Nixis actually does cater to them. They very specifically in Ratchet include an option to disable all TAA, no TAA at all. You can just get completely raw pixels. You can also run it with SMAA if you want, which is, post AA. And it's specifically because there is this subset of gamers that just want these ultra raw pixels and want none of the extra blur or anything associated with TAA. And it's interesting that they will probably never accept stuff like DLSS, right? So it's kind of an uphill battle, and I can see why you get this rise out of certain PC gamers where like they want the option to be able to turn all of that off. And I guess Remnant I don't know if you can actually disable TAA in Remnant though. I think that is actually forced on, but reconstruction is optional.
Okay. I'm not really sure how to take that.
It's more just like, you know, when you're building PC stuff, they're really sensitive to those types of options, and you really need to target this wide audience to make everyone happy. But I guess in the console space, it's not really applicable so much.
Well, there's this really interesting dichotomy in the PC space, which is that you get all of the forward-looking features first, but there's usually a sort of a minority of people who are vocally against any sort of progression in rendering techniques,
like ray tracing,
like reconstruction. You know, basically, you know, the momentum for those features is unstoppable. They're going to be happening. We kind of saw that right from day one when a lot of creators were sort of saying it was a disaster that was never going to gain traction. I mean, the bottom line is developers want to produce better looking games. They want to embrace these new features, and that's why, you know, ray tracing has taken off. Even, and I'm kind of surprised to see that it has taken off in consoles like PlayStation 5 and Series X, when arguably the horsepower isn't really there to get the job done. But
it's just barely there, yeah.
You just see games like Ratchet, for example, and Marvel Spider-Man, where actually you can get a really good presentation.
Metro Exodus, I mean, 60 FPS with RTGI on those consoles, that's remarkable.
And this is
60 FPS in Spider-Man as well.
And Ratchet.
Mm-hmm. Yeah, this is all just sheer will from the developers to make these features actually work for them, because the win is there, right? You know, it's definitely.
Oh, let's not forget Doom Eternal also has a really good ray tracing mode that's super performant. So
yeah, it's quite interesting though. Doom Eternal, you don't actually get the main benefit of the ray tracing until, you know, playing through the first level, because the first level isn't really.
Yeah, because it's RT reflections, and most of the
Mm.
first level is very like stones and bricks and not a lot of reflective materials. But then after that, there's a ton of reflective materials, and it looks awesome.